Okay, last video of the booklet. So, um, what we're looking at now is group data rather than discrete data. So as we said before, discrete data was if we were looking at the length of pine cone here, right? Discrete data could mean, right, I've got a pine cone which is 20.1 millimeters, 20.3 millimeters, 20.8 millimeters, and 20.9 millimeters, and then I've got 22.5 millimeters, etc. You can see that what someone's done is in a grouped table, they've made an interval between 20 and 21 and counted how many fall within that interval. So you can see here 1, 2, 3, 4 bits of data fall within that interval, and therefore it's got a frequency of 4. All right. That's the difference between discrete and group data, and that's the problem with it because you no longer have the individual entries. We don't actually know what the lengths of each of these 4 pine cones were. All we know is that they fell between 20 and 21 millimeters. Okay. Now, with all these problems, you need to check for continuity because at the moment there is a gap. There's 21, so 20 to 21, and this one starts at 22. So what happens if we had a pine cone which was measured at 21.3? Where would we put it? It's not in 22 and it's not in 21, or so it seems. So we can't have any gaps in our data. And the reason why this, the reason why there's a gap is that this length of the pine cone has been rounded, right? So we need to make these lengths, the groups, fall into the upper and lower bounds of 20 and 21. So what I'm saying is that 20 should be seen really as 19.5, and this should be 21.5. And therefore 22, which has a lower bound of 21.5, can go to 23.5. So now there's no gap between any number. So if I did have 21.3, I know that needs to fall within this category here. So your first thing is always to check whether the group data is continuous and there's no gap between numbers. So all of this needs to change. 5, 26.5, 29.5. Great. Now the formula for finding the mean of group data is sigma xf over sigma f. So it means times your x and your f together and add them up. That's what that sigma means. And then divide it all by the total number of frequency. How do you do that though if the lengths of pine cones are given as an interval? At the moment, a length of a pine cone is between 19.5 and 21.5. So what we do is we take the assumption that each pine cone on average is going to be the mid value of each group. So the mid value between 19.5 and 21.5 is going to be 20.5, right? So this is our 20.5. And then we're going to have 22.5, and we're going to have 25, and we're going to have 28, okay? So what we're saying is then that we're going to assume that we found 10 pine cones of length 28, which of course is not completely accurate, which is why we say estimate the mean from a grouped frequency table. That's all we can produce, an estimate. So in order to fulfill this criteria of the formula, we need to work out what xf is then. So x times f. So in our calculator, we're going to times that stuff together. So we've got 20.5 times 4, which is 82. And we've got 22.5 times 21. So that's 472.5. And then we've got 25 squared, so 625. And we've got 280. So underneath here, we can put our total. This is going to be our sigma xf. I like doing sigma xf rather than sigma fx because for standard deviation, a lot of students get this wrong and they write sigma fx squared and they don't know what it means. So actually, sigma x squared f and sigma xf makes more sense, okay? And then we've got our total sigma f on here. So what's the total frequency, the total number of pine cones that were looked at? Well, there were 60, so we know this is 60 on the bottom. And here, what is x times f? All added up, so 82 plus 472.5 plus 65 plus 280. So that is 1459.5. So 1459.5 divided by 60, it is 24.325, and that's your mean, denoted by x bar. Let's do that one more time then, a bit quicker. So, but this time we could use the calculator to know whether we're correct. And again, if we're looking at this, like we say, so we already know what the answer is, but we could use our calculator to speed this whole thing up. So we know this needs to be continuous because it's not continuous, right? And there's a gap between our numbers. So that has to be looked at before you do anything else, just as standard, okay? And therefore, we've got our midpoint values, which we found before. So there's 20.5, 22.5, 25, and 28. And we know that that x bar is the same as sigma xf all over sigma f. Now we can just use our calculator to do this whole thing for us. So why don't you try this along with me? Okay, so go to our calculator, and this is the calculator that you should have now for A level. You go to menu and you go to stats, which is number 6. You're going to go to one variable, right? And if you have this situation where you don't have an F, because you need an F for the frequency column, you need to press shift and setup, and then you need to press down, and then you can see number 3 is statistics. So shift menu, you can press down and then press 3 for statistics, and it says frequency on or off. So we switch that on. So it says X here, so X are midpoint values, so 20.5 and 22.5 and 25 and 28. I really hope this works because otherwise we've got to do the whole video again. That would suck. And then we've got frequency is 4, and then we've got 21 for frequency, 25 and 10. Cool. And then what we do is we're going to press options and then one variable counts, which is number 3. And you can see our sigma x at the top here is 24.325. Yay, we did get it correct. So can you see that on there? It won't let me write it. But you can see in that top column there, x bar 24.325. Hooray! So for the booklet, good to do a manual, but also good to check your answer on the calculator.